In this section, we're going to be looking at angle of elevation. So when looking up at an object, the angle of elevation is formed by the observer's line of sight and a horizontal line. So I really like this picture because here we can see the individual. This is their line of sight, right? This here is the angle of elevation. This is where our theta is going to be located. Okay, so for these following examples, we're going to be using a lot of the knowledge we've already obtained, except now we're adding this terminology called the angle of elevation. So Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. So in this particular case, here is our Casey. Here's her line of sight. This is going to be the lighthouse. And we know that the lighthouse is 84 feet tall. Casey is 6 feet tall, so we know that she's 6 feet. She's tall. How far is he standing from the base of the lighthouse? So now we want to know, what is this distance here? So what happens now is in order to use the work that we've been doing so far, we really need to turn this into a triangle. So notice I can go like this, right? And turn this in here. So I know that this elevation here, this angle of elevation is 58 degrees. Okay. I want to know how far, so I'm really looking for this x value here. And if the entire lighthouse is 84 feet, this height here is going to be that 84 feet of the lighthouse, subtracting the 6 feet of height of the individual here. So 84 minus those 6 feet, that's going to give us a 78 feet here. Okay, so now we have a opposite and an adjacent. So this tells me that the best trig function here is going to be tangent. So I'm going to take tangent of the angle of elevation, and that's going to be equal to 78 over x. Go ahead and multiply both sides by x. I get x times tangent of 58 degrees equals 78. We're going to divide both sides by tangent, and I get 78 divided by tan of 58 degrees, which gives me, come over here to our calculator, 78 divided by tangent of 58 in degrees. So we hit enter, we get 48.7. So this is going to be 48.7 feet. So this is a word problem, so we should answer in words. So how far is he standing from the base of the lighthouse? We say that he is standing 48.7 feet from the base of that lighthouse. All right, let's do another one. Let's look at number 2. The angle of elevation from a kicker's foot of the football to the top of the goalpost bars is 17 degrees. So here, we're trying to get to that goalpost. We know that this right here is 17 degrees from, the kicker. Here's his foot. Okay. And so let's see what else. If he is standing 131 feet from the base of the goalpost, how tall is the goalpost? So here we know that he is 131 feet away. Right. So this is our right triangle here. Right. So let's go ahead and calculate this. I am trying to figure out what is the height of the goalpost. So we're looking for this x value here. So the best one in this case would be a tangent. So we take tangent of that 17 degrees is equal to x over 131. And we're multiplying 131 on both sides. This is equal to x. So then we get that x is 40.1 feet. Okay, so we'd say that the goalpost is 40.1 feet tall. Okay. All right, go ahead and take a moment and try the next two. All right, for number 3, we have Leah's mom is staying at the bottom of the slide of the playground, waiting for Leah to slide down. If the angle of elevation from the bottom of the slide to the top is 46 degrees. So we really need to be paying attention when we're working with angle of elevation is where is that position of that angle. In that first problem that we did, we saw that it was based off of the line of sight, right? The sight is at the top, right? And so versus here, it's talking about the angle being at the bottom of the slide. So that's the 46 degrees kind of going up. The slide has a vertical height of 9 feet, so this is what we have here. And so really here we're left with a sine function. So we're going to be using sine 46 degrees is equal to 9 over x. Kind of solving it that way. Now, a dog is standing 5 feet from the base of a tree looking up at a cat that has climbed 16 feet to the tree. Again, that angle of elevation from the point of the dog is standing, from where the dog is standing. So now we're looking for a theta. And so here is, that line of sight, but then we know that the tree is 16 feet and the dog is 5 feet away from the tree. So we're trying to find what is that angle, that theta, of where from that angle of elevation. Okay. All right, so let's kind of move on here. Now, this is another type of angle, and oftentimes in word problems, students get these confused, the angle of elevation versus the angle of depression. All right, so let's look here. When looking down to an object, the angle of depression is formed by the observer's line of sight and a horizontal line. So here's the observer's line of sight. The angle here, this will be our theta, that creates that angle of depression. And then here's the line of sight. So here's our horizontal line, not our line of sight. That helps create that angle of depression with our line of sight. Now, the angle of depression is congruent, meaning same. So this means the same to the angle of elevation because they are alternating interior angles. So let's do a real quick review of some geometry. So if we have two horizontal lines that are parallel, right, and then they are transverse with a transversal line, right? So here are my two horizontal lines, here are my transversal lines. So then you can see here that the angle here, let's call this theta 1. This angle would be an angle of depression because here's the horizontal line, here is the line of sight, if you want to call, right? And so this is an angle of depression. So we'll just abbreviate angle of depression. And now on this side over here, this theta, this is our theta 2. Right, and so here again, it's against this horizontal line. Now this, again, this stays the line of sight, and now we can see that these two are interior, alternate interior angles. So therefore, this tells us that theta 1 is equal to theta 2. So they are in fact congruent to each other. We can kind of see it here, right? So here's the angle of depression, right? And here we can see that this angle is going to be equivalent to that, and this would be an angle of elevation from the swimmer to the lifeguard. Sorry, drew a blank on the name there. All right, so that's what this is telling us here in terms of the congruency of those angles. All right, let's take a look at this. It says directions, draw and label a diagram. Then solve the missing part, round to the nearest tenth. So we're going to keep rounding to that missing tenth here. All right, so a lifeguard, this goes back to that picture up there. A lifeguard is sitting at the platform looking down at a swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground, so let's kind of take this picture here. So here's the lifeguard kind of sitting down at his chair. Something like that, right? Here's my little swimmer guy with his hands and his feet kicking. So lifeguard's platform to the swimmer in the water. The lifeguard's line of sight is 8 feet above the ground. So here we're looking at 8 feet above the ground. And then we have the angle of depression up to the swimmer is 18 degrees. So let's draw that, our line of sight here. Right, and so remember, here's our horizontal line. That angle of depression is this one right here. This is going to be the 18 degrees, okay? And I know that looks greater than 18. And so it says, how far away is the swimmer from the lifeguard? So we really want to know, okay, well, what is this distance here? This is going to be our x value of the distance, okay? All right, so because this is 18 degrees, right, and we know that they are congruent, that means that this angle right here is also going to be 18 degrees. So notice that even though that angle is on the outside of that triangle, I can replace that angle here because we do know that in fact that they are congruent. All right, so this does create a right angle here. And so if we want to redraw this triangle just to look like a triangle, we're going to see that we are solving for something that looks like this. 18 degrees, this is 8, and I want to know what is this x here. All right, so we can see here that because I don't know the hypotenuse, the best trig function for me to use is going to be that tangent function. So I'm going to take tangent of 18 degrees, and that's going to equal, it's going to equal 8 over x. Okay, so we're going to multiply both sides by x. Here's our tangent of 18 degrees, and this equals 8. And then we have x equals 8 over tangent of 18 degrees. Let's plug that into our Desmos calculator here. So we have 8 divided by tangent of 18 degrees. And we get 24.62. So that means that our x is going to equal 24.6 feet. All right, for completion, let's just get our sentence out of the way. So we have the swimmer is 24.6 feet away from the lifeguard. All right. All right, let's look at the next question. We'll do one more, and then I'll let you all do the last two here. So a pilot in a helicopter spots a landing pad below. So here's my helicopter. You hear the blades? Spots a landing pad below in an angle of depression of 73 degrees, right? So from the line of sight, right, that angle of depression, see if I can draw a semi-straight line here. This angle right here is going to be the 73 degrees. And the horizontal distance to the pad is 1,200 feet. What is the altitude of the helicopter? So this is our landing pad, if you will. I'll say X marks the spot. So from our helicopter to that landing pad, right, we know that this is going to be 1,200 feet. So we want to know, well, what is this here? This becomes our X question, right? So let's turn this into a nicer looking triangle, just without the illustration. So because the angle of depression is out here, remember I have that congruent angle, so I know that that's the same angle here. So this is going to be that 73 degrees. I know that this is 1,200 feet, and I know I'm looking for this X here. So then looking at it this way, I figure out that the best trig function for me to use is going to be tangent again. So I'm going to take the tangent of 73 degrees is equal to 1,200 over x. Let's go ahead and multiply x on both sides. And then I'm going to divide by tangent. And so I get all over tangent 73 degrees. So we're going to go ahead and plug that into the Desmos calculator. So I'm going to have that. Oh, wait, did I do that correctly? Hold on, let's go back over here. Oh, I set it up wrong again. Whoops, I apologize, class. Glad I caught that. So it's going to be opposite over adjacent. And so I set it up as if, so then I'm going to have 1,200 tan of 73 degrees is equal to x. So therefore our x value, now let's come back over here to the calculator. So I have 1,200, we're going to multiply that by the tangent of 73 degrees. It was 73 degrees, so we get 3,925.02. So let's round that to the nearest tenth. So that tells us that we're going to get x equals 3,925 feet. So for completion, let's go ahead and write that out. And so it would be the helicopter is 3,925 feet above ground. Okay. All right, take a moment and try numbers 7 and 8. All right, let's take a look at number 7 first. So a building A is 480 feet tall and building B is 654 feet tall. If the angle of depression, so you can notice here, here's my building A, 480 feet tall. Here's my building B, standing at 654 feet tall. My angle of depression from building B to building A is going to be that 42. So notice here I drew this triangle here. And because we have those congruent angles, we know that this is going to be 42 degrees also to look upward towards building B. So we are able to generate this triangle, which I've simplified over here. And we are really looking for the distance of how far away building A and B are from each other. So we have this triangle, really finding that x below. And so the height of that triangle is really going to be the difference of those two buildings. So we're going to take that 654 and subtract the 480 and get a height of 174. So that's what we're using in the triangle to calculate that distance between the two buildings. So we're going to use tangent. So we have tangent of 42 degrees is equal to 174 over x. We go ahead and do the calculations, and we obtain that the difference, the distance in between the buildings is 193.2 feet. And of course, a small sentence. All right, for number 8, we have Zach is standing at the top of a lookout tower and spots a water fountain below. The lookout tower is 75 feet tall, and the angle of depression is 28 degrees. So here's Zach standing up here. We have that angle of depression is at 28 degrees. Here's our water fountain, or my attempt at a water fountain. And so that depression angle is going to be congruent to this angle here, so we know that this is also 28 degrees. So we can kind of see this triangle here forming. I redrew it over here, so we have 75 is the height, because that's the height of that tower. We want to know how far away from a horizontal distance is Zach from that water fountain. So we turned it into a triangle like this. We are dealing with tangent again, but this time we have 75 over x. And then we go ahead and solve, and we obtain that x is equal to 141.1 feet. So the horizontal distance between Zach and that water fountain is going to be 141.1 feet in terms of distance. And that's the end of this section.